Dear students, welcome back after your summer vacations. So today in mathematics, I am going to introduce a new topic called trigonometry. Now, trigonometry is that branch of mathematics which deals with triangles. Now, all of you know what is a triangle. Suppose ABC is a triangle. All of you know that in a triangle, mainly there are 6 components, the 3 sides, that is AB, BC, CA, and 3 angles, that is angle A, angle B, angle C. Clear? So in a triangle, there are 3 sides, AB, BC, CA in this case, and 3 angles, that is angle A, angle B, and angle C. So trigonometry deals with these sides and angles. Okay. Now in class 10th, you will study only those triangles in which one angle is 90 degrees. Means we are concerned with the right angle triangles only. The right angle triangles. Now, as I told you, in a right angle triangle, one angle is 90 degree. So, if it is ABC, so you can see angle B is 90 degree. So, now out of 6 components, one component is fixed, that is angle B is 90 degree, one angle is 90 degree. So, we are left with 5 components, that is angle A, angle C, AB, BC, and CA. Now we have 5 components. So in this topic, we will deal with these 5 components. Now, as it is a right angle triangle, you know there is a theorem relating all the 3 sides of this triangle, which is called the Pythagoras theorem. All of you know that Pythagoras theorem says that in a right angle triangle, AB square plus BC square is equal to AC square. Okay? So that is a relation between the 3 sides of the triangle. Similarly, you know, as in a triangle, the sum of all the 3 angles is 180, that is the angle sum property of a triangle, and one angle is 90, that means the sum of the remaining 2 angles will be 90 degree. So angle A plus angle C is equal to 90 degree. This relation you know because you have already studied the angle sum property of a triangle. And AB square plus BC square is equal to AC square. That is the Pythagoras theorem. So these two you already know. But now we are interested in finding some relations between the sides and the remaining angles. Means any relation which relates the remaining angles of this right angle triangle and the sides. Now, for that there are few trigonometrical ratios. So first of all, I am going to tell you what are those trigonometrical ratios. So all of you pay attention. Trigonometrical ratios. Now there is a triangle ABC in which angle B is 90 degrees. As I told you that in a triangle there are 3 angles and one angle is 90, so we are left with only 2 angles. So out of the 2 angles, we can take any one of them as reference angle. Suppose I take this angle as a reference angle. Clear? Now the reference angle can be taken A also. So here I am taking angle C as reference. Now what is the difference when we take C as a reference angle or A as a reference angle? Let me explain. All of you know that in a right angle triangle this AC is called the hypotenuse. This AC is called the hypotenuse always. In short, we will write HYP. Clear? That is the hypotenuse. Now, if angle C is the reference angle, then AB is called the perpendicular or opposite. It is also called the opposite, as it is opposite to angle C, so it is called the opposite. Clear? So AC is always the hypotenuse, the side which is in front of angle 90 degrees, and the side opposite to the reference angle is called the perpendicular or opposite, and the side which is making the reference angle is called the base or adjacent. It is called the base or adjacent. Clear? So I repeat, in a right angle triangle, the side opposite to angle B is always the hypotenuse. The side opposite to the reference angle will be called the perpendicular or opposite, and the side making the reference angle will be the base or the adjacent. Now suppose we take A as the reference angle. In that case, this BC will become the perpendicular and this AB will become the base. Although BC is at the base, but we will call it as perpendicular and AB as the base. Is it clear? So always remember, the side opposite to the reference angle is the perpendicular and the side making the reference angle is the base. Now there are few trigonometrical ratios which are used to connect these angles and the sides. So the first one is sine, and in short we write it as SIN only. Okay, and C, the angle is C. So this is sine C, or we write it as sine C in short. I told you sine C, the angle is C here, is equal to perpendicular upon hypotenuse. The length of the perpendicular divided by length of the hypotenuse gives you the sine C. Actually it is SINE, sine, but in short we write SIN. Sine C is perpendicular upon hypotenuse. The next one is cosine. Next trigonometrical ratio is cosine. So cosine C, and in short we call it cos C. Okay, so it is sine C, which is in short called SIN, sine C. Cosine C, in short it is called cos C. We use these only during doing the sums. We use these only. Now the cos C will be base upon hypotenuse. So here obviously perpendicular means AB, and the base and the hypotenuse is AC. Similarly here the base is BC and the height and the hypotenuse is AC. Clear? And the third one is tangent C, or now in short this tangent is called the tan C. Tan C is equal to perpendicular upon base. Here it will be AB upon BC. Okay, so you must remember these ratios because in various questions we have to use them. Clear? So tangent C or tan C is perpendicular upon base, that is AB upon BC. Now the reciprocal of tangent or tan is called the cotangent. So cotangent C, or in short we call it cot. So cot C, cotangent C or the cot C is actually 1 upon tan C. That is base upon perpendicular, and that is BC upon AB. Base upon perpendicular, or it is BC upon AB. Clear? Now the reciprocal of cosine is called the secant. So secant C, or we call it sec. Okay, the reciprocal of secant is sec, and it is equal to 1 upon cos C. It is 1 upon cos C, and that will be, you can see it is hypotenuse upon base, that means AC upon BC. Okay, and we are left with one more, and that is the reciprocal of sine will be cosecant. Clear? So I'll write it here. Cosecant C, or now in short the cosecant is called the cosec. So cosec is equal to 1 upon sine C, as I told you, and 1 upon sine C means hypotenuse upon perpendicular, and that is AC upon AB. Clear? So first of all you must remember these things. Clear? Because in various questions we have to use them. So I'll write it again for you. ABC triangle. This time I have taken this angle as theta. Now sine theta is perpendicular upon hypotenuse, that is AB upon AC. Cos theta is base upon hypotenuse, that is BC upon AC. Tan theta, that is perpendicular upon base, that is AB upon BC. Cot theta, which is the reciprocal of tan theta, is base upon perpendicular, so it is equal to BC upon AB. And sec theta, which is the reciprocal of cos theta, it is hypotenuse upon base, that means it is equal to AC upon BC. And the last but not the least, cosec theta is the reciprocal of sine theta, is hypotenuse upon perpendicular, that is AC upon AB. Okay? Okay, now one thing you must notice, in triangle ABC or in any right angle triangle, you know that the hypotenuse is the longest side. That means AB is less than AC and BC is also less than AC. Now here sine theta is AB upon AC. means the numerator is always smaller than the denominator because AC is the longest side. So in any fraction, if the numerator is always less than the denominator, so that fraction is always less than 1. That means the first thing, sine theta is always less than 1. Sine theta is always less than 1 as AB is always less than AC. Okay, sine theta is always less than 1 as AB is always less than AC. Similarly, cos theta is BC upon AC. Again, BC is always less than AC. So cos theta is always less than 1. Clear? Same thing as in sine theta, cos theta is always less than 1. As BC is always less than AC, because BC is always less than AC, so cos theta is always less than 1. Clear? One more thing, see, tan theta I have written AB upon BC. Now AB upon BC can be written as AB upon AC into AC upon BC, because I have, you can see I have divided by AC and multiplied by AC, that we can do in any fraction. Now AB upon AC is nothing but sine theta. AB upon AC is what? Sine theta. And AC upon BC is 1 upon cos theta. So in place of AC upon BC, if you write 1 upon cos theta, then it is sine theta upon cos theta. So one more important formula is tan theta is equal to sine theta upon cos theta. So these formulae, these facts, and one more formula, tan theta is equal to sine theta upon cos theta. So now we will do few questions based on these formulae. Okay. Given tan A is equal to 4 by 3, find the other trigonometrical ratios. Okay, so they have given that tan is 4 by 3, then you have to find the other trigonometrical ratios. So first of all, I am going to make a triangle like this, A, B, C. As I told you that in class 10th, we are concerned with only right angle triangles. So in each and every question almost we have to use right angle triangle. So ABC is a right angle triangle, right angle at B. Now they have given tan A is 4 by 3, means A is the reference angle. So this is the perpendicular, this is the base, this is obviously the hypotenuse, and you know that tan A or tan theta is perpendicular upon base. In this way we can say the length of BC is 4A and the length of BA will be 3A. We cannot say that exactly the length of BC is 4 centimeter and 3 centimeter because it is only the ratio. That is why I have written 4A and 3A. Now using Pythagoras theorem, we will find AC. So using Pythagoras theorem in triangle ABC, AB square plus BC square is equal to AC square. 3A square plus 4A square is equal to AC square. 9A square plus 16A square is equal to AC square. 25A square is equal to AC square. So that gives you AC is equal to 5A. So we have found that AC is 5A. We have found that length of AC is 5A. Now we are going to write sine theta. You know that sine theta, you must know that sine theta is perpendicular upon hypotenuse, means means BC upon AC. BC and not sine theta, sine A, you write, because angle of reference is A here. So sine A is perpendicular upon hypotenuse, that is BC upon AC, that is 4A upon 5A. A cancelled out, it is 4 by 5. And you can verify the fact that sine A is less than 1. 4 by 5 is 0.8, which is less than 1. Now cos A. Cos A is base upon hypotenuse, which is here AB upon AC. Now AB is 3A and AC is 5A. Again A gets cancelled and 3 upon 5 is cos A. Once again you can verify the fact that cos of any angle is always less than 1, because 3 upon 5 is what? 0.6, which is less than 1. Now tan A they have already given. So the next one is cot A. All of you know that cot A is 1 upon tan A. So simply reciprocal tan A, that is 3 by 4. So tan A is 3 by 4. Now the cot A is 3 by 4. Next, the fourth one is sec A. All of you know that sec A is 1 upon cos A. 1 upon cos A means reciprocal of cos A, that is 5 by 3. And next one is cosec A. So cosec A is 1 upon sin A, reciprocal of sin A, that is 5 by 4. And that is your answer. Clear? These all are your answers. Okay? So we'll continue. The next question. The next question is, there is a triangle ABC which is right angled at C. ABC is a triangle which is right angled at C. Now the length of AB is given 29 centimeter and length of BC is given 21 centimeter. Now angle ABC, that means this angle, is given theta. Angle ABC is given theta. Now you have to find, first part you have to find cos square theta plus sin square theta. Second part, cos square theta minus sin square theta. So first of all what we do, we apply Pythagoras theorem. We apply Pythagoras theorem to find the third side of the triangle, that is AC. So using Pythagoras theorem in triangle ABC, AC square plus BC square is equal to AB square. AC square plus 21 square is equal to 29 square. AC square plus 441 is equal to 29 into 29. (841). So AC square is equal to 400. AC is equal to 20 centimeters. So we have found that AC is 20 centimeters. Okay. We have found that AC is 20 centimeters. Now, sine theta, all of you know, sine is perpendicular upon hypotenuse. That means AC upon, see, when this is the angle of reference, this is the perpendicular. AC upon AB, 20 upon 29. Okay, and cos theta, always remember these trigonometrical ratios, sine, cos, tan, cot, sec, all of them, they are ratios. So no unit will be there. This is in centimeter, this is in centimeter, it cancels, so no unit will be left. Now cos theta is base upon hypotenuse. The base is BC, the hypotenuse is AB, so it is 21 upon 29. So we have found sine theta and cos theta. Now the first part that we have to find is cos square theta plus sine square theta. Now actually cos square theta means cos theta whole square, always remember. And sine square theta means sine theta whole square. Now cos square theta means 21 upon 29 square. And sine theta square means 20 upon 29 square. Now 21 square is 441 upon 29 square is 841 plus 400 20 square upon 841. Now if you take 841 LCM, then 441 plus 400, that is 841 upon 841, which is nothing but 1, and that is your answer. So cos square theta plus sine square theta, we are getting it is equal to 1. Okay, and now the second one, second part, cos theta whole square minus sine theta whole square. Now cos theta is 21 upon 29 whole square minus 20 upon 29 whole square. Now 441 upon 841 minus 400 upon 841. Take 841 LCM. So 441 minus 400, which is nothing but 41. So 41 upon 841, that is your answer. So we have found that cos square theta plus sine square theta is 1 and cos square theta minus sine square theta will be 41 upon 841. Clear? Okay. Now the next question. In the next question, there is a triangle ABC in which angle B is 90 degree. ABC is a triangle in which angle B is 90 degrees and it is given that tan A is equal to 1. Now if tan A is 1, all of you know that tan A is perpendicular upon base. That means if this is the angle of reference or the reference angle, this will be the perpendicular or this will be the base. So we will do one thing, we will change it. We will write A here for the convenience and C here. Now tan A is perpendicular upon base, which is equal to 1. That means perpendicular and base are equal. So suppose this is A and this is also A. Clear? Then only you can see tan A is perpendicular upon base, that is A upon A, that will be 1. Now using Pythagoras, we will find AC. So before that, let me finish the question. Verify that 2 sin A cos A is equal to 1. That is, you have to verify it. You have to check whether it is true or false. So using Pythagoras theorem in triangle ABC, we will find AC. Using Pythagoras theorem in triangle ABC, AB square plus BC square is equal to AC square. Small a square plus small a square is equal to AC square. AC square is equal to 2a square. So AC will be equal to under root 2a square, which is nothing but a root 2. So we have found that the length of AC is a root 2. Okay. Now sin A. Sin A, you know it is perpendicular upon hypotenuse, means BC upon AC, that is A upon A root 2, A gets cancelled, 1 upon root 2. Cos A, that is base upon hypotenuse, that is AB upon AC, which is A upon A root 2 once again. A gets cancelled, so 1 upon root 2 once again. So you can see we have found that sin A and cos A both are 1 by root 2. Now the left hand side of the expression that we have to verify is 2 sin A cos A. That is 2 into sin A is 1 by root 2 and cos A is also 1 by root 2. Now root 2 into root 2 gives you 2. That means 2 upon 2, that is 1, and that is right hand side. So you can see we have verified that the left hand side is equal to right hand side. 2 sin A is equal to 1, that we have verified that left hand side is equal to right hand side. Clear? Now we will do the next question. There is a triangle OPQ in which angle P is 90 degrees. There is a triangle OPQ in which angle P is 90 degrees. The length of OP is given 7 centimeter. The length and it is given that OQ minus PQ is equal to 1 centimeter. It is given that OQ minus PQ is 1 centimeter. So find sin Q and cos Q. You have to find sin Q and cos Q. So first of all, using Pythagoras theorem in triangle OPQ, as it is a right angle triangle, so we can apply the Pythagoras theorem anytime. So using Pythagoras theorem in triangle OPQ, OP square plus PQ square is equal to OQ square. Now OP square means 7 square plus PQ square is equal to, now see from this relation, which is the given relation, OQ is nothing but PQ plus 1. If you shift PQ on the other side, OQ will be equal to PQ plus 1. So in place of OQ, you write PQ plus 1 whole square, like this. Okay? Now 7 square is 49 plus PQ square is equal to, now here we will apply the formula A plus B whole square. All of you know A plus B whole square is A square plus 2AB plus B square. Means PQ square plus 2 into PQ into 1 plus 1 square, that is 1. Okay, the formula that we have applied here is a plus b whole square is equal to a square plus 2ab plus b square. Okay, now pq square gets cancelled, so 49 is equal to 2pq plus 1, that means 48 is equal to 2pq. So we have found that pq is equal to 24 centimeter, because 48 upon 2 will be 24. So we have found that pq is 24 centimeter, and if pq is 24, so 24 plus 1, oq will be 25 centimeter. So you can see, using Pythagoras we have found that PQ is 24 centimeter and OQ is 25 centimeter. And now we have to find sine Q. Sine Q. Now see, as Q is the angle of reference or reference angle, so OP is the perpendicular, OQ is the hypotenuse, and PQ is the base. So sine Q is perpendicular upon hypotenuse, that is OP upon OQ, that is 7 upon 25. Okay, and cos Q is base upon hypotenuse, that is PQ upon OQ, that is 24 upon 25. Okay, so sine Q is 7 upon 25 and cos Q is 24 upon 25. That is your answer. Okay, so we'll go to the next question. Next question, there is a triangle PQR in which angle Q is 90 degree, and it is given that length of PQ is 12 centimeter and length of PR is 13 centimeter, and you have to find tan P minus cot R. You have to find tan P minus cot R. So first of all, using Pythagoras theorem, we will find the third side QR. Using Pythagoras theorem in triangle PQR, PQ square plus QR square is equal to PR square. 12 square plus QR square is equal to 13 square. 144 plus QR square is equal to 169. So QR square will be equal to 25. That gives you QR is equal to 5 centimeter. So we have found QR is equal to 5 centimeter. Now we have to find tan P and cot R. Now see, first of all I am going to find tan P, that is perpendicular upon base. Now see, when I am writing tan P, that means P is the reference angle. So this becomes perpendicular and this becomes base. So it is 5 by 12 because the perpendicular is 5 and the base is 12. Now I have to find cot R. So cot R. Now although cot is base upon perpendicular, but now as R is the reference angle, this becomes perpendicular and this becomes base, so it is 5 by 12 once again, 5 by 12. Now tan P minus cot R is equal to 5 by 12 minus 5 by 12, and that is nothing but 0. So the answer is 0. 5 by 12 minus 5 by 12 gives you 0. Okay, now We'll do one more question. And the question is, if sin A is equal to 3 by 4, find cos A and tan A. If sin A is 3 by 4, find cos A and tan A. So first of all, you make a triangle in which you take angle B as 90 degree. Now sin A is given 3 by 4. All of you know that sin is perpendicular upon hypotenuse. Here, if A is the reference angle, then BC will be the perpendicular, AC will be the hypotenuse. As sin is 3 by 4, so this side will be 3 and this side will be 4. Clear? Or we can write 3A and 4A, because exactly the length is not 3 centimeter and 4 centimeter. So you can write 3 and 4. Now using Pythagoras theorem, we will find the third side, that is AB. So using Pythagoras theorem in triangle ABC, using Pythagoras theorem in triangle ABC, AB square plus BC square is equal to AC square. That is AB square plus 3A square is equal to 4A square. That is AB square plus 9A square is equal to 16A square. That is AB square is equal to 16A square minus 9A square gives you 7A square. So AB will be equal to under root 7A square, which is nothing but A root 7. So we have found that length of AB will be A root 7. Okay? And now you have to find cos A. So all of you know cos A means base upon hypotenuse. Base upon hypotenuse. That is A root 7 upon 4A. A gets cancelled. So it is root 7 upon 4. Base upon hypotenuse. And tan A is perpendicular. Tan A is perpendicular upon base. Here the perpendicular is 3A and the base is A root 7. Once again A cancels out, so it is 3 upon root 7. So we have found that tan A is 3 upon root 7 and cos A is root 7 by 4. That is your answer. So I hope whatever I explained today is clear to you. Do the sums given in your assignments and we'll continue with the topic in the next class. Okay.